Hi everyone, this is Dr. Omar. In today video clip I will show you step by step how to do non-parametric test in SPSS. There are mainly 4 major non-parametric tests that are usually in common use in SPSS. Before we start, I need to describe 2 important types of data. Data can be either qualitative means that it comes in categories, such as, and these categories can be either nominal, no order, like names of individuals, sex of individuals, male or females, or qualitative data can be ordinal, i.e. they are in ranks, like A, B, C, D, first, second, third, low, medium, high. So the first type is qualitative, the second type is quantitative, which is measurable. It's a numerical scale, and then quantitative can be either continuous or discrete. Continuous is continuous data or variable are data that has number in it from 0.1, 0.5, 2, 0.5, 3 and so on. Discrete data that comes in integer 1, 2, 3, 4, 5. Right. So what does non-parametric data mean? When we can call that now that these data are non-parametric in a samples. We can call this data are non-parametric when the samples are not normally distributed. The distribution of the value of this data in the group are not normally distributed and shift from the normal shape of the curve. The sample size are not equal. One sample is larger than the other. The sample size is very small. One or two samples, one of the samples is less than 30, or both of them. Then these data probably to do a comparison on them, you need a non-parametric. They are called non-parametric, and they need non-parametric test for them. The samples are ordinals. Ordinal mean, as I explained, they come in order 1, 2, 3, 4, like a questionnaire. You do have a questionnaire, and the answer in the questionnaire either I totally disagree, I agree, it doesn't matter, I strongly agree, and so on. The data contain an outliers, a very extreme value of these data. One of the measurements or the value of the data is very high or extremely very low compared to the data. Now, what are the major non-parametric tests that can be used in SPSS? There are 4 major non-parametric tests, and there are 2 factors determine which one of them to use. The first factor is whether the samples are related or not related, and what is the size of the sample or the groups. So if you have 2 groups that are unrelated, or 2 samples that are unrelated, and you want to compare these 2 groups and these data on the group, and those groups are non-parametric, then we use a Mann-Whitney U test. Another test that really have the similar to Mann-Whitney U test is Wilcoxon rank sum test. If you have more than 2 groups, 3 groups, 4 and 5 and so on, and your groups or samples are unrelated, then Kskal Wallis test is the one to use. Then we follow that by post hoc test, and I will explain later on why do we need to do the second test following doing the first one. However, if your data comes in a groups and these groups are related, they are paired, and you have two groups or two samples, then Wilcoxon signed rank test is the one to use to compare those two groups. And if you have more than two groups, 3, 4, 5, and these groups are related, participant or individual has different measures in different groups, then Friedman Anova test the one to use for non-parametric test, followed by post hoc test, and I will explain that in subsequent slides and show you how to do it in Spss. So how does this test briefly works? The non-parametric test, in fact, take the actual data, sort the data in ranks, and compare the median and calculate the p-value. The first non-parametric test is Mann-Whitney U test. Another test that can be used also called Wilcoxon rank sum test. Both of these tests are used to compare and calculate significant difference between two groups. These groups or samples are unrelated, not paired, independent. So the test, Mann-Whitney U test, is non-parametric test, equivalent to two sample independent t-test. The test compares the differences between two unrelated, not paired, unpaired samples or independent samples. Analysis is carried on the rank rather than the actual data. The test finds the lowest score and gives it rank 1, then finds the next higher score and gives it rank 2, and so on. So put the data, sort the data in ranks. The highest score have the higher rank, and the lowest score is represented by low rank. The test calculates the medians for each sample. In this test, only the median are used and calculated. The test is used for these types of data. The data that are not parametric, data are scale or continuous but not normally distributed. The sample size or the group size is small and the data in it or participant in it less than 30. The data in the groups are ordinal, i.e. from 1 to 5. Now to do a Mann-Whitney U test in Spss, here I have data for two groups, group number 1 and group number 2. Group number 1 is males, group number 2 is females. Body weight was measured for both groups. We can see here that the male group has 10 participants in it and the female 10 participants. So it's a small group. The two group or samples are not related, and the weight measurement is not normally distributed. I have checked that. So we need to compare these two groups, the male group to female group, and find out if there is a difference in the body weight between females and males. And since these data are not normally distributed and it's non-parametrics, the test that to use is Mann-Whitney U test. And to do that, we click on Analyze, scroll down to Non-parametric tests, then scroll down to Legacy Dialog, then scroll down to Independent Samples. Since these two groups are not related, independent, we click on the two independent samples. A new window will appear, and here we need to move the gender, male or female, into the grouping variable, and we need to define these groups. We said that group 1 is 1 and group 2 is 2, as I had given value for each one of them. Click continue. Then we need to move the weight variable into test variable list box, and we need to make sure that the ManWhitneyU test icon is ticked. Click on exact. You will see a window. We will not change any of these parameters or conditions. We'll stick to it. We click on continue, and then we click on option. We're going to select descriptive. Give us the statistics, descriptive statistics. Click on continue, then hit the button for OK. The SPSS will produce an output giving 3 different tables. The first table is just descriptive statistics. We have just selected. It shows here that there are 20 cases, 20 participants, and it's calculated the mean for the weight and standard deviation and minimum and maximum. The second table is the Mann-Whitney test output. Here, as you can see, it's labeled ranks. What does the test do or did? What did the test do? Took the actual data for the male and female body weight, sort them into ranks, and then calculated the mean rank. And we can see here the mean rank for the female is higher than the mean rank for the male. The third table shows the statistics, the test and the p-value and the value for the test. The software calculated the Mann-Whitney U test value and the Wilcoxon value, and also the significance of the differences between the two groups. And we can see here from this table that there is a significant differences between the body weight of females compared to males, as the p-value is less than 0.05, and the females tend to have more body weight or higher weight than male. Females have higher weight than males. So this is the way to do Mann-Whitney U test or Wilcoxon test in SPSS using a non-parametric data. The second non-parametric test is Wilcoxon signed rank test in SPSS. This test is used to compare two groups or samples that are paired. So it is a non-parametric test equivalent to two paired t-tests. The test compares two related or dependent samples or repeated measure on a single sample. You have the same participant and separate measurement has been taken on that participant or individual or case. So it's the same person, so the data are related or paired. Again, the test compares the medians, and the test is used for data that are not normally distributed. The test also used when the sample size is small. To use the test, you need to at least have 5 paired samples, at least 5 participants in the data or individuals. The variables within the data can be either ordinal, interval, ratio, or continuous. So I will show you then how to do Wilcoxon signed rank test in SPSS. Here I have a file with the data in it for 10 participants from 1 to 10. They have been given a treatment with a certain drug, and a measurement has been taken before treatment and post treatment. So each individual here or participant have a measurement before the treatment and post treatment. So the sample here or the individual or these variables are paired, they are related, they are dependent because they are from the same individual. So this group is very small. You have 10 measurements in each group, and the size is small, and I've checked the distribution of these data and I found that they are not normally distributed. So they are paired, 2 groups, and they are paired. So the best test to do is non-parametric test, the Wilcoxon signed rank test. And the way to do that is to click on Analyze, scroll down to Non-parametric test, then scroll down to Legacy Dialogues, and then scroll down to 2 related samples, because these samples are paired, so they are related. So we click on 2 related samples, a window will appear, okay, and then in this window it say what pairs do you want to test. So what I want to test is pre-treatment, post-treatment. So this is the pre-treatment. I'll click that and transfer it to variable number 1, and then I'll click on the post-treatment and transfer that into variable 2, and then I'll make sure that Wilcoxon test is ticked. If I click on exact, I'll get this window. So we're not going to do any changes here, we just click on continue. And if you click on options, you will get another window. We are going to tick for descriptive to get more descriptive data analysis. Click on continue. Now here in this window we just hit the button for OK. SPSS will generate 3 tables, or an output that have 3 tables in it. The first table is descriptive, showing that you have 10 pre-treatment and 10 post-treatment, and calculate the mean for each treatment and standard deviation. The second table is the important one, as it is the output for Wilcoxon signed ranks test. Again, it took the data, actual data from each group, and put them into ranks, and then calculated the mean rank for each. Okay. The third table is the table that shows the statistical significance for the differences between the pre-treatment and post-treatment. And again, the software Spss has calculated the p-value and found to be less than 0.05. So it is 0.005. So there is From this data, we can confidently state that there is a difference between pre-treatment and post-treatment, and this difference is significant. This is the way to do a non-parametric test on paired groups in SPSS using Wilcoxon signed ranks test. The third non-parametric test is Kruskal Wallis test. This test is used when you have 3 groups or more, and those groups have data on them. The data are not parametric, they are not normally distributed. The test is equivalent to ANOVA. It is one way ANOVA on ranks. The test is based on ranking data. It takes the actual data, put them into rank, and then calculate the significant difference between groups. The data in the groups are not related. They are not paired. They are independent from each other. The test determines a statistically significant difference between the medians of 3 or more independent groups. The test compares more than 2 independent samples of equal or different sample size. To do the test, the data are not normally distributed. This test is for not normally distributed data. The data can be either ordinal or continuous. Now, Kskal test calculates the significant differences between all groups, whether you have 3, 4, 5, but it doesn't identify which 2 groups are significantly different and which are not. And to find out that, can do it by 2 different ways. The first one is through using Mann-Whitney U test, which I've described above previously. And the other one is post hoc. Post hoc test perform multiple comparisons between all combinations of groups. I'm going shortly to show you how to do these follow-up 2 tests, the Mann-Whitney U test and post hoc test, to find out which 2 groups are significant and which are not. In this, go to SPSS. In this SPSS data view, I have a data from 21 participants divided into 3 groups. Each group has 7 individuals in it. Group 1, I gave it number 1, number 2, and number 3. Group 1 is a control. Group 2 is 1 week. Group 3 is 2 weeks. And those individuals were participating in a trial on a drug that has been introduced recently. Measurement has been taken, and this measurement for each group is not normally distributed, and the sample size in each group is small, 7, and these 3 groups are not related, they are independent. So the best way to find if there is a differences between all these groups is to use a Kskal Wallis test. And the way to do that is to click on Analyze, scroll down to Non-parametric tests, then scroll down to Legacy Dialogues. Then, since these groups are independent, we're going to click on the K independent samples. A window will pop up, so we need to make sure that Kskal Wallis test is clicked on. We need to move the test variable list into this box, as we are going to analyze these data, and we are going to group this variable by participant. And I need to define the range because we've selected the range from 1 control to the maximum 3, which is 2 weeks. Hit the button for OK. If you click in exact, you will get a window. We'll not do any changes here. You just click on continue. On options, we'll select here under statistics, put a tick on descriptive, click continue. Now we are ready to hit the button for OK. What Spss do, generate 3 tables. The first one is descriptive statistics, showing that there are 21 participants. This is the mean for all these participants, and this is the standard deviation. The second table is the Kruskal Wallis test. Test is being carried out, and we have 3 groups: control, week 1, week 2, and in each group there are 7 individuals, total 21. The test took the data in each group, then sort them into ranks. So for the control, the mean rank is 4.2, and for week 1 13, and for week 2 is 14.9. The third table is the statistics. The Kskal statistics has calculated the p-value for the 3 groups. Compare the 3 groups and calculate the p-value, and the p-value found to be less than 0.05. So this indicates that there is a significant difference between these 3 groups. But the Kskal Wallis test doesn't tell you which 2 groups are significant and which are not. It's just give you an overall significance between the 3 groups. And the way to find out which groups significant and which not is through 2 methods, as I said, either through using ManWhitneyU Test or through post hoc. We'll start with ManWhitneyU Test. If we go to analyze, scroll down to non-parametrics, and then legacy dialog, and then we'll go click on 2 independent samples, because these 2 samples are independent. So we're going to put the participant variable here, and we're going to compare the control with the week 1. Okay, and then the drug, we'll move that into test variable list, and then we make sure that we click on Mann-Whitney. Click on exact, we'll keep it the same. Click on option, we'll keep the descriptive, and then we click on OK. So again, the software has done a test, Mann-Whitney test for control and 1 week, and generate a p-value. Then I can go back again and do Mann-Whitney tests in sample and control compared to 3, which is here week 2 weeks. Click on continue, click on OK. Again, the Mann-Whitney test gives here 2 tables, or 3 if we select the descriptive. Let's give you a compared control to 2 weeks, and calculated the significance of the test, the comparison, and it's the p-value is less than 0.0, so there is 0.05, so there is significance here. Again, it's give you the mean rank. Again, we need to do that for the rest. So we've selected 1 with 2, 1 with 3. Now we will select 2 with 3. Hit the button, click OK. Here, the Mann-Whitney has compared week 2, 2 weeks or 4 weeks period or window, and it's found out that there is no significance. So what does this data tell you? Says that there is, first of all, with the Kruskal Wallis, there is a difference between the 3 groups. Now, which 2 groups are significant and which are not, the difference between them? We used Mann-Whitney. Mann-Whitney used compared control to week 1, found it significant. Then compared control to week 2 found it significant, but when it's compared week 2 to week to 1 week to 2 week, it's found, or week 1 to 2 weeks, it's found out there is no significance here. Now this is the way to find out which two groups are significant using the Mann-Whitney. Another way is to go something called post hoc test. And the way to do post hoc test is to click on Analyze, scroll down to Non-parametric test, and then scroll down here until you find something called independent samples, since they are independent. Click on that. We'll get some window here. So in this window, what we are going to do in the objective, we're going to customize the analysis. In the field, we're going to drag the participant into the groups and the drug into the field, test field. And then we'll go to the setting, and in the setting also I will click on customize test, and I will find here that there is an icon called Kskal Wallis test one-way ANOVA samples. Click on that and it say multiple comparison using all pairs. Hit the button for run, and the Spss will generate a small table like this one, the post hoc test. Is saying though that there is statistical differences between the three groups, so we will reject the null hypothesis. If we double click on this table, we'll get another table, another window. It show you all these graphs. Now if we scroll down here into pairwise comparison, another table will be generated. In this table you will see that the post hoc took the control and compared it to week 1, control to week 2, and week 1 and to week 2. Again, week 1 and week 2 is insignificant. Control 1 to week and control to 2 weeks, there is a significant. Again, this way I have shown you how to do Kruskal Wallis test for a group, for a data that are in 3 groups or more, and these groups are not related, and the groups are not parametric, and then the Kruskal Wallis test calculated the p-value, then followed that by either Mann-Whitney or post hoc test to find which two groups are significant and which are not. The fourth non-parametric test is Friedmans Anova test. This test is used when you have 3 groups or more, and these groups are related, dependent, and the data on them are non-parametric. The test is non-parametric version of one-way repeated measures ANOVA. Data are not normally distributed. The test compares 3 related samples or groups that have the same subject. Test whether more than 2 related groups differ. Again, it's based on ranking data. The sample size has to be greater than 5 in each group to use this test. Variables are continuous. Now, Friedmans Anova calculates over all statistical differences, significant differences for all groups together and not as a pair. So if you have more than 3 or more, or 5 or 6 and so on, the test will give you a p-value for the difference between all the groups, but not specifying which 2 groups are significant and which are not. And to find out that, you can do it through two methods. The Friedman Anova test can be followed by either Wilcoxon signed rank test, which I had previously described it, or the post hoc test. Wilcoxon signed test is non-parametric test comparing dependent data from only two groups. And the post hoc test is used in order to decide which two groups are significantly different from each other. So once you do the Friedman Anova test, you need to follow it up with either post hoc or Wilcoxon signed rank test to find out which two groups are significant and which are not. In this SPSS window, I have data that has arranged as it's shown here. 10 cases, 10 individual being giving a drug at 0 point control after 2 weeks or after 4 weeks. So the same individual participated in this study. So these groups, group control week 2 and week 4, they are related because they are the same person in each group. The group, in each group there are 10 individuals, so it's a small. The data on it are non-parametric, not normally distributed. So if we want to find that if there is a difference between these three groups, and since they are related, the way to do it is to use Friedman Anova test. So if we click on Analyze, scroll down to Non-parametric test, and then scroll down to Legacy Dialog, and then go straight away to K-related samples. As you can see, a new window will appear. Make sure that the Friedman box is ticked. And then we need to do a comparison between these three groups: control, 2 weeks, and 4 weeks. And then if we click on exact, and then another window will appear. We'll not make any changes here, we just keep it as it is, and then continue. Click on continue. Statistics, we'll tick the descriptive icon. Continue. If we hit the button with OK, SPSS will generate a window, an output showing descriptive statistics. There are 10 individuals participated in this participated in this study, and there are 3 groups: control, week 2, week 4. Calculate the mean and the standard deviation. This data into ranks: the control, the week 2, and the week 4. Put them into ranks and then calculated the mean. Also, the test has generated a p-value and calculated the p-value, and the p-value was found to be significant. Here it's less than 0.05. So this table shows that there are significant difference between control week 2 and week 4. But which one of these two are significant and which are not significant, the Friedman will not be able to show that. The way to show that, as I've had said previously, is either 2 ways: to take each 2 samples and pair them together and do analysis using Wilcoxon signed rank test for each pairs, or to use post hoc. And I'll show you both methods. To start with, we'll start with the Wilcoxon signed test. Click on Analyze, scroll down, Non-parametric, then Legacy Dialog, and then we click on the 2 related samples. A window will appear. In this window, we need to test the pairs between control and week 2, control and week 4, week 2 or 2 weeks, and 4 weeks. Make sure that, as I've shown previously in separate and in part of this presentation, click on keep the Wilcoxon box ticked. If we click in exact, we'll keep the The data, the setting here is exactly the same, will not change anything. Options, we will go for descriptive and click on descriptive, and then click on continue. And if you hit the button OK, the SPSS will do a Wilcoxon signed rank test for all possible combination. Control with week 2, control with week 4, week 2 and week 4. Again, and put them in rank, and then calculate as is shown here, and then calculate the p-value for paired groups. As we can see here, that control and week 2 weeks, comparison between the control and 2 weeks, there is no significant, less than, it is 0.08. However, there is a significant between control and 4 weeks and 2 weeks and 4 weeks, statistically significant. So the Friedman has shown that there is significant difference between the 3 groups, but there's only significant difference between control and week 4 and week 2 and week 4, but there is no significant difference between control and week 2. Another way of doing the comparison between 2 groups together is to use a post hoc test. And to do that, we click on Analyze, Non-parametric. Since these data are related, we click on Related Samples, and then a window will appear asking for objective. What is your objective? I'll just click on Customize Analysis. Then if I click also in the field, and I want to test field, I want to test all these 3, move them to the test field, and then if I click on the settings, also click here on Customize Test, and if you scroll down, you will find an icon for Friedman. Click on that, Friedmans Anova by ranks, and it will say multiple comparison or pairwise. If you hit the button for run, SPSS will generate a table showing that there is a statistical significance between these 3 groups. And if you double click on that table, another window will appear showing the control weeks 2 and week 4. And if you scroll down here and into the related sample test view and click on pairwise comparison, another table will appear. Again, this table had calculated the differences between control on week 2, and it's found to be not significant, between control and week 4 to be significant, between week 2 and week 4 to be significant. So thus I had shown you 2 different methods to follow up Friedman test to find out which 2 pairs of groups have significant and which are not. And as I said, the Friedman Anova test is used for comparing non-parametric groups that are related. Hope it is clear to everyone. Thank you for listening.